Hi everyone, thank you for coming. Oh, that's not. So my senior project was about, oh wait, the remote. So, as of 2017, Google Chromebooks accounted for 59% of all mobile device shipments to United States schools, which is up from only 5% in 2012. This meteoric rise to dominance of the educational technology market is evident even here in Bow. My grade, the class of 2019, will be the first year where everyone has a school-issued Chromebook for all 4 years of high school. Despite all the good things which are enabled by Chromebooks, there are some difficulties in switching over from Mac and Windows. An example of this is in our physics classes, where labs are conducted on the PCs in the physics room. And the switch to Chromebooks means that some software which was used on those Mac and Windows computers will need to be replaced with compatible programs for Chromebooks. So for my senior project, I decided to create a web-based version of the Java-dependent and Chromebook-incompatible Tracker software. My idea was dependent on the fact that Tracker is an open source project, and my final product is also open source. And this means that the source code needed to run both Tracker and my application are available for free online, and they can be modified, replicated, and shared by anyone who's interested. My project leveraged open source in solving a problem that I saw needed fixing, which shows that anyone can contribute and branch off of these projects to help others. So Tracker is used in physics labs to plot the position of moving objects in videos and then extract the kinematics variables from that data. And this is useful in a variety of labs. For example, there's a lab conducted at the beginning of the year where students are tasked with filming an object that is moving with a constant velocity, and then one which is getting faster and faster or accelerating. They then import these videos into Tracker and then plot the motion, which is analyzed. And it's a useful introduction into kinematics and how the data of motion can be looked at graphically. So in April of this year, I was planning to do a hackathon at Dartmouth with some other BHS students. And a hackathon is when a number of teams do different projects over a set amount of time, and then the judges determine the winner, like the best project over that time. And so we were brainstorming different ideas we could do for the hackathon, and we were focusing mainly on web apps. And this got me thinking about what software we used in school which could be replaced with an online version, and I suddenly realized that Tracker was the perfect candidate. We concluded that it was going to be too in-depth of a project for the hackathon because it was only a 24-hour competition, but I thought it would be perfect for my senior project. And not only would this be an awesome learning opportunity for me, but it would also help the students at BHS. I started my project as soon as I got put in the class because I was really excited to get started on it. And the first step in making the project was deciding what frameworks and languages I was going to use to build it, because building from scratch would be unnecessary for this. I knew I wanted to use JavaScript because I wanted this app to be server independent, and I was familiar with the language, and that means that anyone can run it on their computer. They don't actually need it to be running on a web server somewhere else. I decided to use object-oriented syntax for this project because I knew it was going to be long and complex, and it would help me to organize my code. So for my graphics library, I chose to use something called Easel.js, which was recommended by a number of articles and was open source, which means it was perfect for what I needed. I am using other open source libraries on top of Easel.js, but that is what the app is most dependent upon. So the first iteration of my app was pretty ugly. It was just the video, which was hard-coded into it, and then some dots where data was being tracked, and then placeholders where I planned to put the different parts. So next, I added some controls so you could navigate through the video as you were tracking it. And then by the end of school, I had the ability to add scales, place an axis, and track points on a video, all of which were displayed into a data table. So what I continued to work on throughout June and July, I made the workspace scale to the correct size when you resize the window. I allowed the user to edit the important settings for the track, scale, and project. I added the ability to save the project to Google Drive or save it to a file on your computer, and then you can re-import it later and keep editing it. I made it so it would automatically back up your work, so if your computer crashed or something, you would still have your stuff saved. Then I had to improve how the units were handled in the scale and for the data tracks. I implemented undo and redoing your work, and then I made it so you could export the data that it produces easily into an Excel or Sheets document. I also had to make some super in-depth documentation for the students to use the app because I had to make sure they were able to use it without me being there and actually instructing them. And one difference I made in my app was to have it so it doesn't actually calculate the velocity and the acceleration built into it. You actually have to take the position data and then calculate it yourself. And because you have to do it yourself, it helps you to learn more about the technical process and getting the actual velocity and acceleration data instead of just punching them into a graph and not really understanding where they come from. So my final app is at the point where a student can conduct any of the labs we did on Tracker in physics class, and that meets my criteria for the success of the app. This will be a useful tool for the students at Bow and hopefully at other schools. At one point during my project, I got to interact a little bit with the users, all of whom were teachers on the Tracker forum, and they all showed great enthusiasm in what I was making, and this gives me hope that it will be adopted in other schools. So the research component of my project was all about open source and free software, and not only was my research about this, but I made an open source project and it uses all kinds of other open source projects. Although this is a little more technically challenging than most beginners would want to start with, it really isn't too hard to contribute to projects like this. There are millions and millions of open source projects online just waiting for people to get involved. And this can mean so little as updating the formatting of a website. It really doesn't need to be that huge of an undertaking. Contributing to open source may not seem like a huge deal, but collectively countless developers contributing to millions of open source projects help move the world forward. According to GitHub's 2017 Octoverse website, there were 25.3 million active code repositories in 2017, which doesn't even account for the projects that are hosted on other websites. And GitHub is the leading provider for Git version control, which is how most developers manage their code and track the changes that they make. Many open source projects are hosted on there, and Git itself is actually open source too. So these sites have made it very easy to contribute to open source projects, which makes it accessible to anyone with a computer and an internet connection, which everyone at BHS now has in their Chromebook. And this technology is special because it allows anyone to contribute to real code bases, which can teach them how projects like that work and how they're managed and what the actual code looks like for a real professional application. And learning to program is helpful for almost any career because it helps build problem-solving skills and technological abilities. Not only does open source help you learn programming, but it can also help you with other fields. For example, someone interested in physics could look at my app and learn how it works on a lower level instead of just accepting what it outputs at face value. So overall, creating a Chromebook-compatible version of Tracker was a hugely beneficial experience for me, forcing me to creatively solve problems and learn new skills throughout the process. And creating this project demonstrates the power of open source, which allows anyone who is interested to get involved and contribute to these projects. Over the past few decades, open source has allowed so many new developers to learn how to program and practice their skills by contributing to established projects. And learning to program gives you a skill set which can be used across a wide number of fields and can help you with any career path you're interested in. If this inspired you to give programming a shot, there's no better place to start than on my app, and you can check it out here at jst.lucadamian.com. Thank you.